Today's lesson has us looking at different graphs of functions. And so let's look at this beginning part. It says the more you know about a graph of a function, the more you know about the function itself. As you look at this function here, you can see that it is decreasing from here to here. And if you observe the x values there, that is decreasing at the x value from -2 to right here, which is 0. Okay, so from -2 on the x-axis to 0, that's where the function is decreasing. So we could write that as an interval by writing -2, 0, put the x in the middle, and basically by putting these less than or equal to signs in here, you're saying that all the x values between -2 and 0 is where the function is decreasing. It's decreasing from the x value of -2 all the way down to the x value of 0. But then see here, it doesn't decrease anymore, does it? Okay. At this point now, it stays constant. So from 0 to, that is 2, right? Yeah. It's constant. So you would write from 0 to 2. Put your x value in the middle because it's the x values that we're looking at. And then your less than or equal to signs. From 0 to 2 is where it stays constant. And then it starts increasing from 2 up to what? Whoops, that was not real good. From 2 up to what?
4.
What x value? To 4. Very good. So from 2 to 4, all the x values in between there, including 2 and 4, is where the function is then increasing. Okay? And so you've written different intervals. You've written the interval for where the function is decreasing, the interval for where the function is remaining constant, and then the interval for where the function is increasing. Okay? And I know that can be a little difficult to grasp at first, but as we do some more examples, I think you'll be fine. You'll be able to follow along. Okay? All right, so let's look at number 1. On number 1, we have to write where this function is increasing. Now let's look at this function. If I start here, what am I doing right now? Increasing. And I'm still increasing. Don't let this here fool you and make you think that it's stopping or that it's got a flat spot. It's just very gradually increasing. Okay? So on this particular graph, you would say that the function is increasing over the entire interval. That means on all values of x from here, because see, as this continues to go down, it continues to go a little further out. And as this continues to go up, it continues to go a little further out this way. So it's always increasing. So you're going to write all real numbers. So where is the function decreasing? Where's the function decreasing? It's not. It's not decreasing, okay? So we don't need to answer that. What about, is there an area where the function is constant? No, there is not an area where that function is constant either, so there we go. Okay? All right, let's look at number 2, starting with increasing. Okay, you can see here that the function is increasing. Where does it start increasing? We're not exactly sure. It comes all the way up to there, and then it stops increasing. So remember, we're looking at the x-axis. So it's increasing from all the way over here, all the way up until the x value of -1, right? That's -1. Okay, so you could write, because there's no starting point, because it's just coming in from all the x values in the negative direction, it's just coming in this way. You're going to actually write x is less than or equal to -1, because that means any of these values less than or equal to -1, all of these x values here, is where the function is continuing to increase. So there's not a boundary there because you don't have a starting point here. Okay, so that's why it's just the one variable and one number. All right, and then, but let's find another place. Notice here it starts to increase again, doesn't it? All right, and where does it stop? It doesn't stop. It keeps going. So we're going to write and we're going to have another one. Now this one starts at the x value of what? +1. And it goes and goes and goes, and it continues along the x values going out, 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 out. So we would write that as x is greater than or equal to 1. Okay? Because it's not ending. It just keeps going on and on and on. All right, how about an area where it's decreasing? Right here, it's decreasing between what x values? Yes, between -1 and +1, right? Okay, it's the x values we're referring to. And then because it's falling between there, we're going to use our less than or equal to sign. Do you see the difference here? How we have a boundary, we have a start and an end point, versus these just continue to go on and on and on in both directions. All right. So, all right. And then is there an area where it's constant? No, no constant. Okay. Let's look at number 3. Increasing. Here we have an increasing. We don't have an exact starting point, but it goes all the way to what x value? To 0, right? It goes to 0. So it comes in somewhere way over here. So we could write x is what? Less than or equal to 0. Are there any other areas where it is increasing? No. So we're done with that. Okay, let's go now to decreasing. Here's where it's decreasing. And at what point is it decreasing? At what x value?
2.
It's right here at the 2. So x is going further and further down the x-axis. Greater than or equal to 2. Good. What about constant? Is it constant somewhere?
Yes, it is.
Yes, it is. It's constant between
0 and 2.
It's constant between 0 and 2. So the x values that come between 0 and 2, that is where the function is constant. Are we doing okay? Okay. It's a lot of thinking. Okay. And if you remember, we actually did this when we were doing domain. And to be honest, this was some of you struggled with this. Some of you came in for extra graphs to look at, to practice with. I remember that. Okay. All right. Let's take a look here. It says the points of which a function changes its increasing or decreasing or constant are helpful in determining the maximum or minimum values of the function. So see, as this function it's going decreasing, up right there where it changes to increase. That low part is called the minimum. If it's a high part, it's called a maximum. Minimum, maximum. Okay? So frowny faces, they have a maximum. Smiley faces, they have a minimum. And in this particular example, there's 2 minimums and 2 maximums. Okay, number 4. All right, find the intervals where the function is increasing, decreasing, or constant. Okay, and then max and mins. So increasing here. Now this one can be a little bit tricky. It's increasing. You can see it starts increasing right here where the minimum is, right? And it goes on and on and on. So you want to estimate about where is that? What x value do you think that's about at? 0.5 maybe? 0.6? 0.5? We can go with 0.5, 0.6, somewhere in there. So it's increasing for the x values that are greater than or equal to what? 0.5. Sure, we can use that as long as you're close. All right, now let's do the decreasing. Okay, it's decreasing all the way to that point. All right, so it's decreasing for the x values that are less than or equal to 0.5, right? Because it's still coming to that same point, 0.5. All right, are there any constant areas? Any flat lands? Nope. How about any minimums? Yes. Where x is 0.5 is a minimum. Now, let's see if we can write that as an ordered pair. So if x is 0.5, what is y? What is the y value? It looks like 3, doesn't it? About -3? Okay, so let's write that as an ordered pair. And then, are there any maximums? No maximums, so that one's done. There's a lot you can tell from a function by looking at its graph. Min, max, where it's increasing, decreasing, where it's staying constant. All right, let's look at number 5, increasing. What's it doing here? It's decreasing here, then it's increasing, and then it's decreasing. Okay, so it's increasing right about there, right? And I would say that this looks like the -1 and the +1. Would you agree? The little tick marks? 1 and 2, -1 and -2. Okay, so it's increasing between what values? Negative what? What? Negative 0.5 and positive 0.5? Okay. It's increasing between those two values. Where is it decreasing then? X less than or equal to negative 0.5 and greater than or equal to 0.5. Remember, don't look at it as, oh, it's going down, so it's less than. It's going for more positive on the x-axis. We're just looking at the x-axis, okay, for the interval. All right, are there any constant areas? Any flat lands? Flat levels? Nope. Minimums? Yes, we have a minimum. A minimum right here. What would that ordered pair be to the best of your guess? Negative 0.5, comma, negative 0.5, as long as you're close, okay? And then what about the maximum? Here's my maximum. 0.5, 0.5, 0.3, okay, sure. As long as you're close, okay? All right, very good. Let's look at this next picture with the soccer ball. The picture below shows a graph that models the path of a soccer ball. The x-axis represents distance in yards from the center of the soccer field. Okay, so this represents the distance in yards from the center of the soccer field. The y-axis represents the height of the soccer ball. So here is how far it's going across the soccer field, and this is how high the ball is going. Okay, so let's answer some questions here. What interval is the soccer ball increasing in height? On what interval is it increasing? Now, mind you, be really careful here. Do you notice that the soccer ball is not at the maximum? That's kind of deceiving, isn't it? Okay, we want to be really careful that we are looking here. This is our maximum, all right? That's the point where we want to be looking. So it's increasing all the way to right there. Now, it does have to start at some point on here. So anybody want to take a guess?
3.
Let's see. 1, 2. Okay, it looks like it's going to 2.5. So that would be this end, right? I guess the question here is, what goes over here? Now, typically on a graph, we would have an arrow here and just say that it's everything less than the 2.5. The problem is, this is a real life problem, and that we're talking about a soccer ball, and it's not going to keep going down, right? It's going to, right here is the point on the field where it starts, right? So what do you think? -2? I'm thinking probably that would be the case. It does say that the x-axis represents distance in yards from the center of the soccer field. I was kind of guessing that this would be from the center. So you must be back a little bit from the center of the field. Is that how you're interpreting it? Okay. All right, and then what interval is the soccer ball decreasing in height? Well, now it's decreasing from 2.5 to what? 7. What does the maximum represent? What does this represent in terms of the problem itself? The height of the ball. Very good. The height of the ball. Okay? All right, number 7. Now we have a catapult. Do you guys know what a catapult is? It's something that can launch a projectile, an object, into the air. Okay? So a catapult was launched and the projectile followed the path seen in the graph. Use the graph to complete the table below. Each axis is scaled by 1. That just means that we've got, this is 1, 2, 3, 4. It's numbered. It's kind of hard to see, though. Okay, so for the vertex is going to be your max or your min. Okay, in this case, it's our maximum. Okay, so the vertex, what would the ordered pair be for that vertex there? Well, you might have to start counting over. 1, 2, 3, 4, 5, 6. 6, 16. Yep. Okay. How about the y-intercept? The y-intercept is where it crosses the y-axis. What would that ordered pair be? 0, 7. Remember, the first number is how far you go left or right. So 0, 7. All right, then the x-intercept is over here. 14, 0. Okay. The line of symmetry. You may or may not know what a line of symmetry is. Or you may not remember, but I think you would have done it in elementary school. Line of symmetry is a line that cuts the picture in half so that it mirrors on both sides. That is the line of symmetry right here. And a line has an equation. Okay. It's going through at 6. So the equation for a vertical line, how do we write that? Do you remember? It's going through the x-axis, so we write x equals 6. We're not doing concavity. The domain. The domain, remember, is referring to the x values. The x values that are being used here. They go all the way from 0 all the way to, what was this number here? 14. So we would write 0 less than or equal to x less than or equal to 14. Oh, I put that in the wrong spot. That should be here because we weren't doing concavity. Okay, and then the range would be the y values. All right, so what is the lowest y value? Well, if you look here, even though this one over here doesn't start at 0, this one does. So it goes from here all the way up to whatever that is, 16. So we're going to put 0 less than or equal to y, because it's range is y, less than or equal to 16. So we completed the table. That was part A, was to complete the table. Now let's talk about this example. Part B says, what does the x-intercept tell us about the projectile? What does this right here tell us? That's the x-intercept. Tell us about the projectile. That's where what? That's where it lands. Good. It tells us where the object lands. Good. Okay, what about C? What does the y-intercept tell us about the projectile? Here's the y-intercept. What does that? The height? What?
The highest point.
The highest point? The height, yeah, the height where the object is what? Is launched. You could have phrased that differently, but you don't want to put the highest point because the highest point is the maximum. It's the point where the object is launched or catapulted. Okay, D. What does the vertex tell us about the projectile? This is the vertex. The maximum or the minimum can be called the vertex. The vertex tells us what about the projectile? The max height, right? I'm trying to do short phrases for you. Okay, and on what interval is the projectile increasing? What interval is the projectile increasing? Between 0 and 6. Remember the interval? We're just looking on the x-axis. Between 0 and 6 is where it's increasing, from 0 to 6. If we're just going on the x-axis, this is 0, this is 6, so between 0 and 6 is where it's increasing.
Why are we just going to
That's just how you tell what the intervals are. The only time you're going to use the y-axis is if it's asking for range. And on what interval is the projectile decreasing? It's decreasing starting at 6 to what? Between 6 and 14. Very good. All right, number 8. The graph below shows the temperature in degrees Fahrenheit at Central Park during 1 year. On what intervals does the temperature increase? Okay, so you can see that it increases all the way up to here, right? Where does it start? February 1st. Is that where it starts increasing?
Yeah. No. Like in the middle between January, like 20th.
Yeah, it really starts increasing around here, doesn't it? It's okay that it's not directly on one of the dates. We can estimate the date for that. So it's going to increase between January, what? 20th? Okay, sure. And I'm going to go ahead, even though this isn't labeled X, we know that's the X-axis. Just so we're used to writing this interval. The interval is using inequalities. January 20th, less than or equal to X, less than or equal to August 1st. Very good. What does the maximum tell us about the temperature in Central Park? Where's the maximum? Right here. That's the maximum. What does that tell us about the temperature in Central Park? Okay. The highest. Oh goodness, I was going to write height. The highest temperature was about 88 degrees. Or you can put 87. There's not a one, just estimate it. Okay? Part C, on what intervals does the temperature decrease? Okay, well now it's going to decrease starting here at August 1st, going all the way to It does. If you look back, it looks like well, this is for 1 year though. Okay, so thoughts. I think we need 2 separate ones. I think we need to show this, and then I think we need to show this. So let's do the first one. Okay, so it's decreasing between January 1st and what? Yeah, we picked January 20th, so we'll do that. And it starts decreasing from August 1st to what? How many days are in December? 31. Do you see why I did that? Because really, we don't know that the next year that it's going to keep doing that exactly, right? This is a 1 year block. So we had to look at the decrease here at the beginning of the year and the decrease at the end of the year. Okay? All right, number 9 starts another problem. So let me scoot this up. During the 1990s, now you're going to want to listen really carefully with this one, okay? And this is going to finish us up for our lesson. During the 1990s, the sales of bowling equipment in the United States increased and then decreased. Okay, so if we just were thinking about a graph, increased and then decreased, right? I mean, just as you are reading it, you could kind of think the graph might look like that, unless it said that it was going to increase again or something like that. It increased and then decreased according to the model where C is the sales of bowling equipment in millions of dollars, and T represents the year, with corresponding to 1988. The domain is given, domain, that's our what values? X values. The domain is given as the time being between 8 and 16. What year does the number 8 represent? What do you think? 1988, sure. Okay, what do you think the number 16 then represents on the graph? So if 8 is 1988, between 8 and 16 is how many more years?
8.
8 more years. So 8 more years would be,
1996.
there you go, 1996. Okay, and then, all right, now it says the maximum is, and then it gives you this point. Using the description, sketch the graph, label the axis. Okay, I'm going to sketch my graph down here. Okay, we need to make this nice and neat. You guys do you have a spot out to the side you can do yours? It doesn't have to be big. Yeah, right down there across from E, right over here, you can put yours here. Okay. Is there space by the graph right there?
Yeah.
Okay, you can do it there too. I just want to make mine larger so you can definitely see. Can you see it down here?
Yeah.
Okay. All right, so we know that the x-axis has to be labeled between 8 and 16 because that gives us the years 1988 to 1996. However, we don't want to just start at 8. That wouldn't make any sense. Okay, we've got 0 here. My suggestion would be that you count by 2s just so that we can get all the way to 16. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, so that's the years, right? So we need to label years. These are our years. And then going up the y-axis would be the sales, right? That's our sales. Now, looking at the maximum here, we can see our sales go up to almost the number 15. So when we label this, we need to at least get up to 15. I kind of like to keep it consistent and go by 2s again. 2, 4, 6, 8, 10, 12, 14, 16. It's probably good. All right, so the maximum is at 12.3. Okay, well, if I just go a little past the 12, I'm good. Come over here to the little past the 12, and then up to about 14.7. So I'm just going to kind of do this to kind of make sure I stay on target here. And I've got to go also up to 14.78, which this is 14, so it's a little bit past that, isn't it? Do you guys see why I'm doing this with my line, my dash line, so that I make sure that they come together at the best possible area since I'm sketching it? There we go. You could probably do that with 2 fingers. You could have 1 finger here and 1 finger over here, and then where they meet together is where you put your dot. Okay? So this right here is that point right there. It says the maximum. That was our maximum. Okay? Now, we also know from the description earlier that it's going to increase and decrease. Well, this is our maximum, so it needs to increase and then it needs to decrease. Well, we know that it's between these intervals, between 8 and 16. So I would just have it go ahead and kind of start here at 8 and kind of come up and then right back down to the 16, just like that. And that would be sufficient. Okay, so then we have to answer some questions now that we've created our own graph. Part D says, during which years were the sales increasing? Well, you can see they're increasing right here. It increases from here all the way up to here. So it increases from 8 to, what number was that?
12.34.
Okay, so it's going to increase between 8 and 12.341. Would you guys agree? That's where it's increasing. We're looking on the x-axis between 8 and 12.3. And then it starts to decrease starting back at 12.341 all the way to what? To 16. Oh, hold on a minute. I didn't answer the question. I just wrote the intervals there. We need, okay, so this year right here, the 8 was 1988, right? Is that what that says? Okay, so this is 1988, and then this would be I went by 2s, 1990, and then this would be 1992, right? And then 94, and then 1996. Okay, so this is fine. You can leave these intervals here, that's fine. So let's just add to our answers. It's increasing between what years? 1988 and 1990. It's a little past 1992, isn't it? But I would say that's close enough because it's not quite to the next year. So 1992. Okay. And then what about the decreasing one from about 1992 again to 1996? Yes. We should have used, because it says during what years, we should be using the years. You see the difference here, using years versus using the numbers that we had on the graph? They still represent the same thing, but you do want to make sure you're using the years. Okay, is that the last one?